How's it going, guys? Today in this video, we're going to be going over Module 2.3, Day 1. And we're basically this whole module is going to be about solving absolute value equations when, well, not equations, we'll be solving absolute value inequalities. So instead of having an equal sign, we're going to have inequalities greater than, or equal to, less than, or less than or equal to. All right? So this is something I do with my students. I want them to try this out by themselves. We solve this out like we normally do. You get the absolute value, you get the x out of the absolute value on both number 1 and number 2. You have to make those two cases. So if you want, go ahead and pause the video, read the little excerpt if you want to, and try these out yourself. If you don't want to, I'm going to go ahead and get started. So what this little excerpt is just telling us is that when we're solving absolute value equations, it's possible to get 0, 1, or 2 solutions. All right, when we say equation, that means we have an absolute value equal to some number. So the absolute value of some A term is equal to some B, something like that. Right? After an isolated absolute value equals some number. And that was what we saw in 2.2. And we saw that we have in this form, we have an equation like this. We can get 0 solutions, like when we have an absolute value equaling a negative number. We can get one solution. We can get one solution when the absolute value equals 0, or if we have one extraneous solution. Or we can get 2 solutions with pretty much any other scenario where the absolute value is equaling some positive number with no variables outside of the absolute value. All right, but today what we're going to see is what happens when we have an inequality instead of an equal sign. So for number 1, we're going to determine which numbers satisfy the absolute value x is greater than 3. So remember, to get rid of the absolute value, we need to take into consideration that everything inside the absolute value can be positive or negative, right? So the absolute value of x, that could be positive. X inside the absolute value. So that x term, that can be positive or it can be negative. So that's why we make 2 cases. When x is positive, we get x is greater than 3. And when x is negative, that should be greater than 3. So those are our 2 cases. We split it up. And now we need to make sure the x's are isolated so we know exactly what x is greater than or less than 2. On the left side right here, x is greater than 3. That's already set up for us. We don't need to take that any further. But on the right side, I have a negative x, and I just want an x. So I'm going to multiply both sides by a negative 1. So we get x is less than negative 3. And remember, this is one thing I see a lot. When it comes to inequalities, if you multiply or divide by a negative number, no matter what negative number it is, if you multiply or divide by it on both sides, you have to flip the inequality. All right. So negative x is greater than 3. If I multiply a negative 1 on both sides to get rid of that negative 1 with the x, I get x is less than negative 3. You flip the sign. All right. So those are my 2 inequalities. So I'm going to go ahead to my number line, and I'm going to graph it to see exactly what numbers satisfy that. All right. So the first inequality, that's telling me every x value greater than 3. And it's strictly greater than 3, not equal to. So I'll draw a circle at 3, and I want every number greater than it, so everything to the right of it. And then I have x is less than negative 3. So I draw a circle, everything to the left of it, everything less than it. So I see that my solution here will be x is greater than 3, or that's important. Remember, we talked about that in 2.2. So x is greater than 3, or x is less than negative 3. All right, it's 2 different sections on the number line, so I'm either less than negative 3, or I'm greater than 3. I'm one of the 2. All right, but it cannot be both. There's no number that's in both of those at the same time. That's why we use the word or. All right, and now for number 2, we're going to do it the same way. Make our 2 cases. So x is less than 3, negative x, sorry, is less than 3 as well. So x is less than 3, x is greater than negative 3. All right, so this one's going to be a little different. We're going to see on our number line here, we have a 3 and a negative 3. So when x is less than 3, I'm everything this way. And when x is greater than negative 3, I'm everything this way, right? But I see I have some overlap right here. And that overlap will be our answer. All right, it's not every x less than 3, and it's not going to be every x greater than negative 3. All right, because there's going to be some x's that don't satisfy the other part. I don't want to get too into that because I don't want to confuse you, but just remember it's going to be the overlap of our two inequalities. So if you write this as an inequality, or as our answer or solution, we'll say x is less than 3, and that word's important because that's to be both. X is less than 3 and x is greater than -3. Or we can write this as x is greater than -3, less than 3. Least, you go from least to greatest. And we'll talk more about these ors and ands in a few slides in this video anyway. If it's a little confusing, we're going to touch on it some more. But just know if we're overlapping, our x values have to be in that overlap. It has to be inside that overlapping part because it has to satisfy both of those. But if they're separated, like we saw in number 1, we can say x is greater than 3 or x is less than -3. All right, so that was what we do here, an explanation of it. And now we're going to talk about solving absolute value inequalities graphically. So one thing I want to say right now is that pretty much everything we do in this video in 2.3 is very, very similar to what we did in 2.2. The only thing that's going to change is our solutions, and it's basically just going to be at the very last step. Everything we do before is going to be the exact same thing. So here, with solving graphically, we're still going to graph the left side of the inequality and the right side of the inequality separately, like we did with the equations. We should graph the left side of the equation and the right side of the equation separately. We're doing the same thing with inequalities. Once we do that, the point of intersections are still important. And for step number 3 and number 4, this is where it's going to be a little different, or we're figuring out our actual solutions. If the inequality is greater than, underline that. If the inequality is greater than, or greater than or equal to, it could be either, the solution is an interval that includes the graph above the horizontal line. All right, so I'll touch on exactly what that means when we do our two problems, but I'm just going to give you the notes right now. If the inequality is less than, the solution is the interval that includes the graph under the horizontal line. Okay, so let's go ahead and graph our problem number 1, so we can go ahead and I can explain what 3 and 4 actually mean with some visual representations. So remember, we graphed each side of the inequality by themselves. And remember the little trick to graphing these really quickly. Go to your vertex. In this case, it's -3, +1, your HK. So right here. And our A value is 1. We don't have a B value. So our A value is 1. That's our slope. So our graph, it's going to be an uneven V, but it's not a big deal. It's going to look like that. Okay? So that's the left side of the inequality. And now we're going to do the same thing to the right side, which is at 4. Remember, that's the horizontal line right at 4. And that's what we get. And so far, it's the same exact thing we've always done, right? It's the same. We're graphing the same exact way, treat both sides of the inequality differently. We graph them both separately, and this is what we get. So let's go back to the actual inequality and see what it's saying. It's saying that we want this absolute value, so I'm going to do ABS for short. We want that absolute value to be, it's saying greater than. We want it to be greater than 4. So you want every single part of that graph that's greater than that line of 4. Or in other words, we want everything above this line. And that's what the note said. If it's greater than, the solution is the interval that includes the graph above the horizontal line. We want everything greater than 4, everything greater than that line. So we want everything right here. All the inequality, all the parts of the function that's above that line. So I can see, if I look at the points of intersection, the x values of it anyway, that happens at x equals -6, x equals 0. And I can see my solutions are every x value greater than 0, right to the right side right here, this part right here. My solution is every x value greater than that point of intersection at 0. They intersect at x equals 0. That's exactly where the function equals 4, but I want everything greater than 4. So everything to the right of that x value is 0. So x is greater than 0, or I can see the left side right here, everything less than -6. And the inequality says you want everything greater than 4, not greater than or equal to, so we use the word or, and we use x is greater than, not x is greater than or equal to. All right. So on everything to the right of everything to the right of 0 and everything to the left of -6. So we use the word or, and that's our solution. All right. For number 2, we're going to go ahead and do that together. This is going to be a little different. So we're going to treat it the same exact way. We're going to graph the left side and the right side separately. We're going to see where they intersect, because that's where we get our points right here. Those are our points of intersection. So let's go ahead and do it really quickly. We have the left side, the absolute value. Our vertex is at 2, -3. We have a slope of 2. So something like this. It's not perfect, but it's fine. All right. So that's what my function is going to look like on the left, my absolute value function. And now I have this 1. Remember that's the horizontal line. Y equals 1. And I see it intersect at these points right here. At x equals 0. Don't know why it took me so long to see, but also at x equals 4. Those are my point intersections at those 2 points. So let's go back to the actual inequality and see what it's saying. And it's telling me I want the absolute value to be less than 1. I want the absolute value function to be less than 1. So I want everything on the function that's underneath that red line. I want less than, so everything underneath or everything below. And that's what the note said. It said under, but the same thing, right? Everything underneath or below that horizontal line is going to be our solution. So really, it's going to be this part right here. All right? And we see how we're connected. Since we're connected here, that means we're using the word and, because I have to be to the left of 4 and to the right of 0. The solutions are only inside that interval. So I have to be both, to the left of 4 or less than 4 and greater than 0. So let's go ahead and just write this out. So what you can do is write this step by step. So I know my first thing I'm told here is x is greater than, we have to have x is greater than 0. So x is greater than 0. And x has to be less than 4, right? That's what this interval is. Everything to the left of 4 and everything to the right of 0. So I can write this as x is greater than 0 and less than 4. One way to think about it is if you're connected in your interval, your inequality will also be connected. Your solution will also be connected. All right? Connected in the graph, connected with the solution. With the left side on number 1, they're kind of doing their own thing. They're both separated, so your inequality will also be separated. All right, that's kind of how I think about it, and that's how you solve this graphically. It's the exact same thing up until you figure out your solution. So go all the way up to even finding your points of intersection, and then from there you need to figure out, well, is my solution below the line or above? You go back to your equation. If it's below, you just highlight everything below the function. If it's above, you highlight everything above. All right. So let's keep going. Here we're talking about solving absolute value inequalities algebraically. We're going to do some in a bit. So to solve an absolute value inequality algebraically, we're going to isolate the absolute value expression. If the absolute value of x is greater than a, then x is less than negative a, or x is greater than a if a is positive. And if the absolute value of x is less than a, then x is less than a, and x is greater than negative a. You write that as a compound inequality, and that only happens if a is positive. Okay? So we're going to keep going. You can look at that again if you want to, but we're going to do a problem. So for case 1, problem A, we're told we're going to solve the absolute value of 3x plus 6 is greater than or equal to 12. Then we're going to graph the solution. So solving these out is going to be the exact same things we did in 2.2. Isolate the absolute value first, take it out by making your 2 cases, and go from there. All right. So here I'm going to make my 2 cases. 3x plus 6 will be greater than or equal to 12. and also negative of 3x plus 6. Remember, it's the whole value of the absolute value being negative. That's going to be greater than or equal to 12. I'm going to solve the positive side first. Minus 6. 3x is greater than or equal to 6. X is greater than or equal to 2. Now for the negative side, the red side, I'm going to distribute out that negative 1 first. Negative 3x minus 6 is greater than or equal to 12. I do not change the sign of the inequality yet because I didn't do it on both sides. I just distributed a negative on one side. That's okay. It's when you multiply on both sides with a negative that you have to flip the sign. Right, like in this step right here, I'm adding 6 on both sides actually. Before I multiply by anything, I get negative 3x is greater than or equal to 18. And now I'm going to multiply both sides by, or I'm sorry, I'm going to divide both sides by negative 3 because I'm doing that to both sides. That's when I flip the sign to give me x is less than negative 6. All right, so I have my two inequalities right here. And before I actually write my inequality solution, I'm going to graph it. I really do think the previous slide, I don't like that explanation too much because it only happens when A is positive. And also, I don't like just memorizing stuff for math. I like to actually look at it, explain it, and understand exactly what's happening. So I'm always going to graph my solution first, and then I'm going to make my inequality from that. If we don't give you a graph on a quiz or test, like I said, it's just one straight line. Do it yourself. So you can see exactly what's happening, all right? But anyway, I have a negative 6 as an answer and a 2. So I'm going to go ahead and graph both of those, negative 6 and 2. All right, and once I do that, I'm going to graph each part. So I'm going to do the x is greater than or equal to 2 first. So I want everything greater than or equal to. Now that I'm equal to, I can put a filled in dot or a filled in circle at 2. And I want everything greater than it, so everything to the right of it. And when x is less than or equal to negative 6, same thing, it's equal to. So I fill in my circle at negative 6. I want everything less than it or everything to the left of it. So that's going to be my answer. And I can see here that I want every x value less than negative 6 or every x value greater than 2. Right, that's where the word or comes from. That's my disjunction, which reminds me, I think I skipped this part right here in the very beginning. Sorry about that. But all it's telling me is that after value inequalities with a greater than or equal to turn into a disjunct inequality. All right, and that's basically what I just said right here. We can see when we have an absolute value being greater than or equal to, that I have two different solutions going two different ways. So I'm either less than negative 6 or I'm greater than 2. I'm one of the two, right? And that's why I always like to draw my graph first, because I think it just makes writing my inequality much easier. So x is less than or equal to negative 6. I'll put those there. Or x is greater than or equal to 2. All right? And that's where the word or is important, and that's why I like drawing the graph first instead of just memorizing law of greater than. So that means I'm using or, it means it's a disjunction. Instead of memorizing that, you guys would much rather just see that. So you see the graph, I see I'm going two different ways, I have no overlap, so I can see that my solution is going to be one or the other. All right. So for case 1, problem B, this big orange circle, I do want you guys to pause the video, try it out yourself, and see if you fully understand this or not, so you can move on. All right. Okay. Hopefully you paused it. Hopefully you did the problem. But this is what you should have done. So it's already isolated for us, so we don't have to do any extra work there. But you have to make your two cases. When you make your two cases, you should get x is greater than 5 or x is less than negative 2. Those are my two solutions. We graph it first. It just makes it much easier to figure out your inequality. So it's strictly greater than and strictly less than. So they're empty circles. And I want x to be greater than 5, so everything to the right of 5. And I want x to be less than negative 2, so everything to the left of negative 2. I see on my graph, I'm going two different ways. There's no overlap. So I'm one or the other. So I have x greater than 5, or x is less than negative 2. I'm one or the other. I cannot be both because there's no over. All right. Hopefully that made sense. We're going to keep going on to case 2. And this is going to be the other side of the absolute value inequality. When we have less than or less than or equal to, this turns into a conjunction inequality, which is basically the opposite of a disjunction, sorry. It's the opposite of that, where they're going to be connected. All right, instead of having or, we're going to have an and. So conjunction is going to be what we call a compound inequality, or really just the word and. All right, we're going to have a compound inequality, and we're going to have the word and. And I actually want to go back here just to point out this disjunction will always be the word or. All right, just like the big things to remember about these words. Disjunction will be or, because it's disjunct, they're separated. And conjunction will be compound or the word and. All right, so those are the kind of the big things to know about those two words. So on to A, we're going to isolate the absolute value first. We always have to do that first. So we can add 9 to both sides. 3 times the absolute value of 2x plus 6 will be less than 24. Divide by 3. Absolute value of 2x plus 6 is less than 8. Two different cases. The positive 2x plus 6 is less than 8. I'm doing the math a little quickly. This is minus 6 over. X is less than 1. And then for the right side, the negative side, negative 2x plus 6 is less than 8. I'm going to distribute out that the negative inside the parentheses. Add 6. So it's 14. Divide by negative 2. We divided by a negative number, so this is when you flip the sign. X is greater than negative 7. So make that 7 a little better looking. Let's just redo this whole thing. Why not? All right. Sorry about that. I'm just going to redo this really quickly. There we go. All right. So that's what we get. These are my two inequalities. X is less than 1. X is greater than negative 7. So again, I'm always going to graph my stuff first. It just makes it easier for me. You can see exactly what's happening much easier. So I have a 1 and a negative 7. And my x is less than 1. I just need an open circle. And I'm told I want everything to the left of it. I want everything less than it. And when x is greater than negative 7, I want everything greater than negative 7. Everything to the right of it. So I see I have some overlap happening. So I know my solution will only be on the overlap. All right, so my solution is only right there. Okay? So remember, if you're overlapping, your solution will only be on that overlap. All right? So I can see here that my x value, I have some random x value inside of there. I'm less than 1, but also, and I don't say and greater than negative 7. So I'm less than 1 and I'm greater than negative 7 at the same time. So that's why I know this is going to be a compound inequality or a conjunction. So I'm saying x is less than 1 and x is greater than negative 7. I'm both at the same time. So I have a compound inequality. We go least to greatest, so it should be negative 7. So negative 7 will be less than x, which is less than 1. So x will be in that range, from negative 7 up to 1. All right? So for part B, go ahead and pause the video, try it out yourself to see if you'll fully understand this or not. I'm going to pause the video. I'm going to pause that, move that blue square in a bit. All right? So this is what you should have done. So isolate the absolute value first. You should have done the absolute value of 5x plus 3 is less than 38. Make your two different cases. The positive one will give you x is less than or equal to 7. Your negative side will give you x is greater than or equal to negative 41 over 5. And when you, I forgot to put the negative right there. And when you graph it, you get something like that. You want all x values less than 7, but also greater than 41 over 5. So if any x value inside that range, I'm going to be less than 7 and greater than negative 41 over 5. and that's going to get the compound inequality right there. All right. So let's keep going. Now we're going to talk about some special cases. So for part A, before we even talk about special cases, we need to isolate the absolute value. All right. So we're going to isolate it really quickly. X plus 1 is greater than or equal to -6 divided by 2. So I have the absolute value of x plus 1 is greater than or equal to -3. So I actually want you guys to kind of think about this for a second and think, what do you guys think the answer is going to be? I have the absolute value of x plus 1, or some positive number, that's going to be greater than or equal to -3. What x values can I put in that keeps that true? So if you need to pause the video to think about it for a second, please do that. It's good to figure this out yourself. But if you don't, it is a little confusing because here the answer is going to be all real numbers, because like I said, the absolute value of x plus 1 will always be a positive number, and any positive number I choose will be greater than -3. Every single positive number is greater than any negative number, so every single positive number is greater than -3. So my inequality will be like that. X is greater than -infinity, x is less than positive infinity, or in other words, it's just all real numbers. Every single x value works. So no matter what x value I plug in to that equation, I'm going to get a positive number, and it's always going to give me something bigger than -3. And for the graph, just retrace the graph, because it doesn't matter where on the graph you are, it's going to work. And for part B, same thing, we need to isolate it first. So -3 times the absolute value of x minus 5 is greater than 9, divided by -3. Since we divided by a negative number, it's not supposed to be equal to, just less than -3. So I have the absolute value of x minus 5 less than some negative number, some -3. So I'm saying I have some positive number less than -3. So again, if you need to pause the video and do that, but think about it for a bit and think, what do you think the answer is going to be? All right. And when you think about it for a second, we can see that the answer here is going to be no solution, right? Because the absolute value of any number you put in there is always going to be positive, or it's always going to be positive or 0. So it's always going to be positive or 0. So no matter what number I put in there, no matter what I get, I'm always going to get some positive number, and it's always going to be less than -3. It means it's always going to be greater than -3. Every single positive number will always be greater than -3. So no matter what x value I put in there, I'm going to be greater than -3. That's the opposite of what we want. We want x minus absolute value of x minus 5 to be less than -3. So any x value I choose is just not going to make any sense. So here I can just say there's no solution. Inequality, there's nothing to put there. It's no solution. The graph, leave it empty. There's nothing on the graph that works for this problem. So you just leave it blank. All right. But anyway, guys, I think that's the last page of the notes. It is. All right. I don't want to drag this on anymore, guys. Hopefully this was helpful. And that's it.